Today I'm going to be working on an adapter that will allow me to put an oil temperature sensor into an engine block in a hole that's larger than the oil temperature sensor. Now the reason I'm doing this is because there's very little space and I need to try to make this as compact as possible. Here's where I need to put the temperature sensor. There's actually another stud which is currently removed that goes there. And so you can see that it's a very tight fit. There isn't much room. This is the smallest sensor that I can get. And so the idea is to make an adapter that will allow this to fit through. Now, one of the challenges is that this is not flexible right here, this section. And as you can see, it's going to go right near where that stud has to go. I started with this, which is just a 3/8 inch NPT plug. So it's solid on the back, and then on the front it has a hex. And I did some checking on the computer and discovered that I could just bore this out, and that would be perfect for the temperature sensor, the oil temperature sensor, in that it would come out the back, and then I could retap this with 1/4 NPT in the middle. I downloaded the 3D CAD file for this plug from McMaster, and then what I did to it is basically bored out the center to clear the temperature sensor, have the threads down here. These are 1/4 inch NPT, and then you can see I have a slot across here that will allow me to screw this in and out with a wrench. So speaking of the wrench, I designed a custom wrench, and if I hide this here, you can see that this wrench basically fits into the slot, and then it has a hex on the top so that I can get into this tight space, screw it in, and tighten it. So let's start by making the custom wrench. I cut off a short piece of steel rod, of some type of steel, I don't know what type, and then put it into the V-block so that I could hold it. Probed it so that I would find the center and the top of the rod, and then started roughing out the sides of the slot. Once I finished roughing, then it came back to do a finishing pass so that I would have nice surface on the two sides of the slot. After flipping the part over and clamping it back into the vise with the V-block, I used the probe to pick up the top and then the center of the new location. And then it's a fairly simple tool path to cut out the hex shape. For those of you new to the channel, I'm not cutting at the full depth because this machine, it's a ISO 20 taper, and so it's a pretty lightweight machine, and it's a high-speed spindle. It's not designed for high torque, so I'm careful not to put too much force onto the spindle. And then finally a finishing pass to give it a nice smooth surface. Not that it's needed. This is the part that I didn't catch on camera. I bored a hole, used a thread mill to cut the 3/8 NPT threads, and then I could screw the plug in and mill it in place. My goal was to get the temperature sensor as far into the threads as I could to take up as little space as possible. So I tried a number of different holes. This is the fifth one you're seeing here. Boring the hole out, and then the last part is using the thread mill to cut the 3/8 NPT threads. I need a way to tighten the plug once it's converted into an adapter. So I'm milling slots here in the aluminum jig that will allow me to come back with a smaller end mill and cut slots into the adapter itself. To create the adapter, first I take one of the plugs, the hex plugs, and screw it into place. And then I just tighten it down somewhat snugly, and that should be plenty strong enough to keep it from rotating so that I can mill the bore and then the slot. This is milling out the different stepped locations to make room for the temperature sensor, which has some different steps on it. And so I'm basically going down, cleaning up the different areas, and then here boring for the final diameter. This is using a small diameter flat end mill to mill these slots that will fit the wrench so that I can screw it in and screw it out of the actual engine block. And finally using a thread mill to cut the NPT threads on the inside into which the temperature sensor will screw. I made this brass bushing, which has an adapter. Basically, it's 3/8 NPT on the outside and quarter NPT on the inside. And so the idea is I can put this in there. Well, let me show you the fit first. So if I screw this on, you can see that it has a gap there, which is good because that allows me to tighten it. And then it comes flush with the back, which is a really nice fit. Now let me put this in, and you'll see what it looks like. And I apologize for the noise. I'm actually right underneath the flight path for an airport at the moment. And then I made this wrench so that I could tighten this in here. And there's the first version of the wrench. And I'm not going to tighten it a lot, but you can see it protrudes about the same distance as the one that I had before. So if I screw the temperature sensor in now, as it is right here with this orientation, it actually looks like it'll clear this stud, like so. But it may not clear the edge of the pump that goes in here. So I just decided to see if I could recess this even further. So I'll take this out and I'll show you the next version that I made. I created a shorter version of it. So this fits in and it goes deeper into it, but it doesn't leave that many threads for the quarter NPT part. And because there aren't that many threads, I think if this does work, then I might want to do a custom version of this rather than starting with some plugs so that I can have the whole thing be deeper again and just go deeper into the case, which I can certainly do. So if we look at this, and I thread this in, I have tested and I can thread it in when the pump is on here. It's a little bit tight though, even without the pump. I should say I tested this with the, I did test it with the pump, so it is possible to get it in there. And it does fit in a little bit deeper. So let's see, if I put this in here, it's kind of hard to put in with the nuts on. But I did confirm that, again, it's pretty tight. I'd probably have to bend this to make it work, and I don't know whether or not I can do that, so I need to check with the manufacturer. So one thing I can tell is I can't put the stud in there after that's been installed. So I'll go ahead and take this out and then put the stud in and see if I can get it in. As you can see, this is a really, really tight fit. Now I'm going to not put the stud in all the way because it itself is a tight fit. And so what you can see is that with the stud in there, I can't get it into, well, I can get it in. Okay, it took a little bit of fiddling, but I was able to get it in there. Now what I'm running into is this part here, when it's pushing this way, it means that I can't turn that without bending it. So I can put it in when it's upside down like this without any problems, but as soon as I turn it, it starts to hit that and bind. If I shine a flashlight inside of here, you can see that the screw goes quite a bit deeper than the plug actually used. The plug used, I don't know, the first 4 or 5, and it looks like it goes at least 10 deep. I'm going to have to take a photograph and count them. But that means I should be able to make a plug, if I think about it carefully enough, that goes quite a bit deeper because there's plenty of room behind here. And that should help with the interference. At this point, I started to question whether or not this was the right place. I knew other people had installed this sensor on the same engine, so I posted a question on a Facebook group, and one of the people there said, yep, he had it on his engine, and sent this photo showing where it was located. I took another look, and sure enough, there was a plug exactly in the same location that was the correct size for a quarter NPT temperature sensor. So I talked to the mechanic and he said, yep, should be able to put it in there. And as you can see, it fit very nicely on this engine as well. So as you saw from that, it turns out I didn't need to use the adapter that I created, which is a good thing. I was getting pretty nervous. It just didn't feel like things were fitting correctly. I was following the instructions from the manufacturer of the engine monitor on where to put the temperature sensor for this engine, but it was really, really tight and it just didn't seem like it was fitting there. So I was glad I was able to find someone else who had already done this successfully and had a location that was very accessible and very easy to put the oil temperature sensor into there. For those of you who are curious, this is going into a 1978 Cessna aircraft, and this is something where I have always been curious about what's involved in this, so I'm working with a mechanic on this and learning a lot of things. That's also one of the reasons I haven't produced a lot of videos recently, because this entire project is taking a lot longer than I expected. And I'm spending probably 10 hours a week working on that. Please help me grow the channel. Hopefully I'll be able to produce more videos coming in the future. Please subscribe, give me a thumbs up, comment below. Thanks for watching, and I'll see you next time.